In graphing systems of inequalities, linear inequalities to be exact, the first thing we want to do is draw the borders. Now, what do I mean by the borders? What I mean is we want to draw the line as if we're just figuring out, all right, well, we want to draw y equals x minus 2. So draw that first. That's a border. And then the other border would be y equals negative 2/3 x plus 3. So these are the borders that we want to draw. And let's do that first. And we want to make sure we draw them dashed because one's greater than, one's less than, which they just don't have a greater than or equal to or less than or equal to. Like this one over here, number 2, the first inequality has greater than or equal to. So we would draw that line, the border I should say, as a solid line, where these over here and the second one here for number 2 we would draw as dashed. And I think you guys are doing pretty well with that. So the first line, y equals x minus 2, we know that the slope is the number in front of the x as long as the equation is in slope-intercept form. So the slope is 1, the y-intercept is negative 2, so we would draw, put a dot at negative 2, and then using the slope of 1, meaning up 1 and over 1 to the right, we're going to draw another dot, and then I'm going to go ahead and get a credit card. Hold on a second. Okay, so I didn't get a credit card, I actually got an actual ruler. So I want to draw some nice straight lines. So we have, that's the border of the first inequality, and as long as we're here, we might as well go ahead and shade. And we're going to shade here, as you notice, y it says is greater than x minus 2. So that means we're going to go up from the line, and we're going to draw that very lightly. Okay. So y being greater than x minus 2 means we're going to shade above that. And then the other line has an x-intercept of 3, so we're going to put a dot right there, and the slope is negative 2/3. So we could either go down 2 and to the right, 1, 2, 3, put a dot, or we could go up 2 and to the left, 1, 2, 3, and put a dot. Either way, those 3 dots are going to line up. We only need 2 of them, but again, the line has a negative slope. So we want to make sure we're drawing the line down from left to right, because a negative slope means down from left to right. And then it says here that the y values are less than the line, the border. Okay, so if the y values are less, then we're going to go down. From any point on the line, we're going to go down. And as we can see, we had this section which is above the first line. And then we have this section also now that's below the second line, and therefore we get this region. Now what does that mean? It means that every single point, every single ordered pair in this region would make this system of inequalities true, would make both inequalities true. And so we're going to check. That's what you did on the quiz. We're going to or the test. Find any value. Now, if you get lucky enough to shade 0, 0, then that would be a good one to check, because 0 is typically a lot easier to plug in than any other number. And so to check that 0, 0 is indeed a solution to this system, we're going to check and make sure that 0 for x and 0 for y makes the first inequality true. So the question is, if I plug a 0 in for y and a 0 in for x into the first inequality, is that true? In other words, is 0 greater than negative 2? Yes. Okay, let's try 0, 0 in the next inequality. So if we try 0, 0 in the next inequality, 0 for y is 0 less than or equal to negative 2/3 times 0 plus 3. Well, since negative 2/3 times 0 is 0, that term goes away, and we just get 0 is less than 3. Yes, 0 is less than 3, so therefore 0, 0 is indeed a solution, which is why it's in the shaded region. Okay, so that's in a nutshell how to graph these things, but let me also graph number 4, because number 4, I'm sorry, not number 4, number 5. Number 5, y is not by itself. And so, you know what I forgot to do? I forgot to state the steps. So just to reiterate, 1, draw the borders. Number 2, shade the appropriate side, shade the correct side. Okay. And make sure when you draw the borders, it's either dashed or solid, depending on if dashed meaning less than or greater than, and solid meaning that there's also an equal sign, so greater than or equal to or less than or equal to. So that's drawing the borders, shading appropriately, and then darkly shade, the word darkly shade, you know what I mean, I hope. Darkly shade the overlapping region. So wherever we have an overlapping region, that's the part we shade. And then number 4, we check. Check one point in the darkly shaded overlapping region to make sure that it makes both inequalities true. Okay, so we've got that. That only took 6 minutes. And then let's look at number 5, because this is really the only other style of inequality that you're going to have to evaluate and then graph. And the main thing is, the reason why this is different than the other one is because y is not by itself. You can't tell what side of the border that you're going to have to shade. So the first thing you should do, in fact it makes it easier to graph in general, is just solve for y. So let's take this first one and let's solve for y. And before we solve for y, let's rewrite it. And solving for y, there's a couple ways we could do that. I would prefer keeping the y on the left-hand side, so unfortunately it means we're going to have a negative y over there. But we can handle that. So if we subtract 2x from both sides, we get negative y is greater than or equal to. Now we could do ourselves a favor and write the right side. And sorry, you couldn't see that. And write the right side with the x term first. So negative 3 minus 2x is the same thing as negative 2x minus 3. So that's just the property of real numbers. When you add or subtract, when you add two numbers, negative 3 plus negative 2x or negative 2x plus negative 3, that might be a sticking point. I don't know, I hope not. But look at that, meditate on that if that is a sticking point for you. So anyway, what we want to do, again, is we want to get y by itself. In order to get y by itself, we're going to go ahead and divide both sides by negative 1. Now be careful. When you divide by a negative 1, you've got to switch the direction of the inequality symbol. And that's the only thing you really have to worry about here, other than making sure you get the signs right. Negative 2 divided by negative 1 is positive 2x. And then negative 3 divided by negative 1 is a positive 3. So we finally have our border y equals 2x plus 3, meaning we're going to have a y-intercept of 3. We're going to have a slope of 2, up 2 and over 1. Or we can go down 2 and to the left 1. We could do that too, to find another point on the graph. And then look, it's less than or equal to, so we're going to go ahead and draw the border as a solid line. Okay, so we have a solid line, and from the solid line we're less than or equal to, so we go down from any point on the line, which would be this part of the xy plane. Now we're going to do the same thing with the x plus y greater than negative 3. Now this is a little bit easier to solve for, because as soon as we subtract x from both sides, we see that we get y is greater than. And again, here we have that situation again. We could write negative 3 minus x, but that's the same thing as negative x minus 3. And when we have it this way, when we write the inequality this way, we can see that the slope is negative 1, and the y-intercept is negative 3. So we're going to go ahead and put a point right there in the y-intercept of negative 3, and then down 1 and to the right 1. So we're going to have a line that goes down from left to right. And do we draw this solid or dashed? We draw this dashed. Okay, so just a few things to look out for. And this one being dashed. And we have, so we have the borders correct. We have the dashed and solid. Now we just have to figure out what side of this line that we want to shade in. And then it says y is greater than. So from any point on the line we go up, 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 and then you go, okay, got it. Okay, so then we see this is not an overlapping region. This has no points. This has just one. All these points only solve one inequality, but all these points here solve both inequalities. And again, let's go ahead and check. We're lucky we got 0, 0 again, so let's check 0, 0. Question mark. We should have 0, 0 should go ahead and make both equations or both inequalities true. So let's plug 0 in for x, 0 in for y, and ask ourselves, is that a true statement? 0 minus 0, that is 0. Is 0 greater than or equal to negative 3? Yes. Okay, try 0, 0 in the next one. 0 plus 0. Is that greater than, well, it is greater than negative 3. We just said that. 0 is greater than negative 3. Yes. So we have both of those are yes. 0, 0 is in fact a solution to this system of linear inequalities. Therefore, it should be shaded darkly, and it is shaded darkly. All right. So what I'll do is I will pause the video, and I will work out all the rest of the problems. And so then you can try the rest of the problems and then check your answers against my solutions. And maybe, hopefully, by now you've got it down. Here you go, guys. Solutions to the problems that I didn't show the solutions to earlier. So problem number 2, see there. Problem number 3. You can just pause the video when you get to it so you can check it out. I'll go a little bit faster. Problem 4. Problem 6. And problem 7. There you go. See you in the next video.